Okay, today we're going to talk about the elements that make up a hypothesis test. So a hypothesis test is a procedure that we follow when we're testing a claim about some data that we've gathered. That could be data on a mean, or it could be data on a proportion. It actually could even be data on a standard deviation, but we're not going to go there. We're trying to analyze whether our sample results occur normally or by chance, or if the results are unlikely to occur by chance. So if something is unusual or usual. So we have to have two competing theories, and our claimed value is called the null hypothesis, and it has this symbol as shorthand because we don't want to write out null hypothesis all of the time. And our null hypothesis, h sub 0, has to be equal to some value. Okay, so if it's a proportion, it'd be p equals, or no, not p hat, it'd be p equals some proportion. Our alternate hypothesis, I'm going to make up 50% just to give you an example. Alternate hypothesis has this symbol with an h with a subscript of 1. And that's, again, because we don't want to write out alternate hypothesis every time we're doing a hypothesis test. And so this has to differ from our null hypothesis, and it has to either use a less than, a greater than, or a not equal to sign. And let's just do this. Our alternate hypothesis is that our proportion is not equal to 50%. So here, if our alternate hypothesis is, let's say our proportion is less than 50%, we call that a left-tail test. Okay, because we are testing to see if our proportion is in the tail over here. If we're using the greater than sign, so this one's for less than, and it's left-tailed. If we're using the greater than sign, that's a right-tailed test, because we are checking to see if our proportion or our mean value is in the right tail. And then if it's the not equal to, that's called a two-tailed test. Because we're looking for a proportion that isn't equal to something, and it's not in one end or the other, it's in both ends. Okay, so we're going to try a few examples. We want to determine the null hypothesis, that's h with a subscript of 0, the alternative hypothesis, that's the alternate claim, and whether our tail is left-tailed, right-tailed, or two-tailed. So our first example is, according to a Gallup poll conducted in 2008, 80% of Americans felt satisfied with the state of their lives. A researcher wonders if the percentage of satisfied Americans is different today. So the claim is, see if you can pick out the claim. What are we claiming the proportion is? Well, we think that the proportion is 80%. So we use decimal. We don't use percent. And then the alternate hypothesis, this is the claim that we're investigating, is different. That's not is greater than, it's not is less than, it is different, or is not equal to 80%. So if I go ahead and draw that out, is not equal to means we're going to test the proportion, and we're going to make sure that it is not in the tails. So this is a two-tailed test. Our next example. The Blue Book value of a used 3-year-old Chevy Corvette Z06 is $56,130. Grant wonders if the mean price of a 3-year-old Chevy Corvette Z6 is different from $56,130. Okay, so our null hypothesis is going to be some claimed value. So if we are looking for the claim, the Blue Book values claim is that the price is $56,130. So this is not a proportion, this is a mean. So that is my null hypothesis. My alternative hypothesis is Grant wonders if the mean price of a 3-year-old Chevy Corvette is different from $56,000. Again, different from isn't less than or greater than. It's not $56,130. So again, this is, if I draw it out, a two-tailed test. Moving on to our next example. A pharmaceutical company has developed a new antibiotic for children. 2% of children experience headaches as a side effect. A researcher for the FDA wishes to know if the percentage of children having the side effect is more than 2%. Okay, so 2% is what we're claiming. Percent, that's a proportion. So P equals 0.02. Our claim that we're challenging that because we're wondering if P is actually greater than 0.02. Greater than is we're testing to see if the value is in the right tail. One of the ways I remember that is this points in the direction of the tail. Kind of dorky, I know. But for me, it makes it easier to remember. So this is a right-tailed test. And the key to that is more than 2%. Okay, last example. I want you to turn the video off, try this yourself, and turn it back on when you're ready to check your answer. Okay, federal law requires that a jar of peanut butter that is labeled as containing 32 ounces has to contain 32 ounces. A consumer advocate believes that a certain manufacturer is shorting customers by underfilling the jars. So my null hypothesis, the claim is that a jar holds 32 ounces, and that's not a proportion, so that's going to be a mean. So our null hypothesis is that our mean is 32 ounces. And then our alternate hypothesis, where the consumer advocate is checking a claim that the jars are underfilled, so that means the mean would be less than 32 ounces. So I would be looking in the left tail of this curve to see if my value follows in that region. And again, that inequality points to the left tail. So there are 4 different outcomes that can happen from hypothesis testing. I can accept, or I don't ever accept, but I can fail to reject the null hypothesis. And the null hypothesis is true. That would be a correct assumption, right? If I don't reject this and it's true, so fail to reject, and it's true, that's a correct assumption. Or I could reject my null hypothesis. And my alternate hypothesis could be true. So that would also be a correct assumption. But I can also fail to reject my null hypothesis, and my null hypothesis could be false. That would be an error. And then I could reject my null hypothesis, and my alternative hypothesis could be false. This would also be an error. So I have two different conclusions that could be correct conclusions, and I have two different scenarios or two different types of errors. If we think about a courtroom, I'm going to draw a little table here. So if I think about a courtroom, and I think about being on a jury, the null hypothesis, if we think about a defendant, we're always going to assume the defendant is guilty. Just kidding. We always assume innocence. And the alternative hypothesis is the defendant is guilty. So if we're on that jury, we have those two hypotheses. And we can fail to reject, or we can reject them. All right. So one thing that could happen is that our null hypothesis is true, and we fail to reject. This would be a correct decision. We could have a situation where the defendant is innocent, but we reject that he is innocent and we find him guilty. This would be a type 1 error. Okay. We could have that the defendant is guilty, we reject the null hypothesis, and that would be also a correct decision, that we find the defendant guilty and the defendant is guilty. It could also happen that the defendant is guilty, but we find him innocent, and that would be a type 2 error. Of the two errors, a type 1 is a more serious error because we would be sending an innocent person to jail. And it's a more serious type of error in statistics too. Okay, so let's practice figuring out what a type 1 and a type 2 error looks like. So for each example, we're going to give the null and alternative hypothesis and state what it means to make a type 1 or a type 2 error. So the first example is according to the U.S. Census Bureau, 10.5% of registered births in the United States in 2007 were to teenage mothers. A sociologist believes that this percentage has increased since 2007. So the claim is 10.5%. So that is our null hypothesis. Since it's a percent, that's going to be our proportion, not a mean. The alternative to that, the challenge we're making, is that the sociologist believes that this percentage has increased. So he doesn't think it's less than that. They think it's more than 10.5%. So that will be a right tail test. And a type 1 error would be that 10.5% of births are to teenage mothers. But the sociologist thinks that the percentage is higher. Yeah. Okay, that's a type 1 error. That's when our null hypothesis is true, but we reject it. A type 2 error would be that the percentage of births to teenage mothers is higher than 10.5%, but the sociologist believes that it's 10.5%. I think I spelled believes wrong. Whatever. Nope, that was right the first time. Okay, so that's a type 2 error. When our alternate hypothesis is true, but we fail to reject the null hypothesis. All right, so I want you to try this one. Come up with your null hypothesis, your alternative hypothesis, and then decide what kind of test it will be, and determine what a type 1 error would look like and a type 2 error would look like. Okay, let's check your answer. According to the Wireless Association, the mean monthly cell phone bill was $48 in 2010. A researcher suspects the mean monthly cell phone bill is different today. So our null hypothesis is going to be that the mean, because it's a mean, not a percentage, is equal to $48. And our alternative hypothesis is that our mean does not equal $48 because it's different, which makes it a two-tailed test. And then a type 1 error would be that the mean monthly phone bill is $48 and the researcher concludes that it's not. So that our null hypothesis is true. The mean monthly bill is $48, but the researcher concludes that it isn't. And a type 2 error would be that the mean monthly phone bill is not $48, but the researcher concludes that it is. Okay, that's all we're going to talk about today. We'll learn actually how to finish a hypothesis test in the next video.